automatic question answering. In this lecture, I will consider basically factoid based question answering. But first we will go through some use of automatic question answering, like frequently asked questions, FAQs. It is also used in help desk or customer service phone centers. It is useful in assessing complex set of technical maintenance manual. Means you ask some maintenance, you ask questions related to some maintenance and system will automatically respond you. Even in help desk you may ask some question and an automated system can respond you. Another thing is integrated question answering in knowledge management and portals. You can use the such facility in improving your knowledge. A wide variety of other e-business and applications you can use. So there are a huge amount of use of automatic question answering. Recently iPhone also considers the features like automatic question answering. You can ask some questions and it replies you. Now we will give some introduction. Factoid based question. It is the most widely studied task in question answering. It is a fast growing research area. Bring together the research from information retrieval, information extraction and natural language processing. And it is a very challenging applications and methods developed for question answering systems are very closely related to other areas like document retrieval, time and named entity, expression recognition, etc. Some important points like basic factoid questions like when was X born? In what year did Y take place? These are the basic factoid questions. We can answer such questions either in a single word or some set of words or in a single sentence also. Some recent research trend is shifting towards more complex type of questions such as definitional question like who is Hillary Clinton and entity definition questions like what is DNA. Some questions like list type of questions like list the countries that have won the World Cup. Scenario based question answer. Given a short description of a scenario, answer questions about relation between entities mentioned in the scenario. Why type of questions like why sky is blue, why do we laugh, etc. Now how to evaluate. Now these are the basic techniques, basic types of varieties of question answering, automatic question answering. Now entire question answering system is still in development phase. So to calculate the accuracy of the machine generated answer, we use some metric. Actually in factoid based question answering there may be one or at most a few correct answers to a given question, and answer in most of the cases may be single word, token or short noun phrases. The system returns one or more ranked answer candidates for each question. Track and Clef uses the following parameters to judge the answer. First is correct. Means if you produce the ranked set of answers, then your first ranked answer match with correct answer provided or annotated by human. Second is unsupported. If either the doc ID was missing or wrong, or the supportive snippets do not contain the exact answer, then such machine generated answers are marked as unsupported answer, inexact. If contains less or more information then that required by the question. Example, if question asks for year but answering contains both year and month, then this measurement techniques mark such answers as inexact. Fourth is incorrect, if the answer does not provide the required information. The other measurement unit is mean reciprocal rank. Several times machine generated answer, in machine generated answer, we see a ranked list of answer similar to the search engine generated pages. Search engine generally generates ranked list of URLs for any search keywords. In the same way, the automatic question answering system several times generates a ranked list of answers. To calculate the accuracy of such generated answers, we use mean reciprocal rank. In mean reciprocal rank, this part is called reciprocal rank. For example, in model answer or annotated answer, answer is given and your system generated answer suppose answer is at fourth rank. This answer present as fourth position, then this will be equivalent to 1/4. So for a given set of questions, it calculates the mean of all such reciprocal ranks and finally give the quality of your question answering system. Brief overview of some question answering system. In a question answer evaluation track, each system is given a document collection, a set of training question, gold standard answer, and a set of testing questions. The document collection may contains newswire articles, some knowledge base, or some other documents. Generally, such collection contains millions of documents. A typical question answering system usually apply a pipeline architecture that chains together three main modules. First is the question analysis model. In this model, we analyze the question, identify the named entity or keywords or type of question, and then by using the identified keywords, we try to identify the particular try to form a particular strategy to identify the answer. And we also try to identify the dependency between keywords given in questions, or try to identify the sense of questions. For this we use some question analysis techniques which use syntactic or semantic analysis, dependency parsing, sentiment role labeling, etc. These are the general question analysis model. Document or passage retrieval model. In this model, we use the keyword produced by the question analysis model and try to identify some set of documents which are relevant for that answer. This operation is very similar to the search engine operation, which identify the set of URLs for a given query. And after that, the third stage is answer extraction model. By using some relevant set of documents, we identify the the extracted list of answers, or we generate the extracted list of answers. The answer extraction model performs detailed analysis and pinpoint the answer to the question. Usually, answer extraction model produces a list of answers candidates and rank them according to their scoring functions. So this is the process traditionally used for automatic question answering system. This is the general architecture for question answering system. For example, this is a question. What is Calvados? This is a question, and this is question classification and pre-processing. Here we partition the questions into several parts, and after that information retrieval, we use the query Calvados is text retrieval functions applied, which identify the set of useful documents which contains these keywords or query ranked list of documents, and after that we apply the answer extraction framework, which identify or rank the particular set of ranked list of answers according to the relevance to the given question. For example, this is a sample answer example, and after that this is a generated answer list. Question for answer Calvados is a dry apple brandy. Now these are the approaches. A structured knowledge based approach for question answering. This is a very simple approach. First is direct knowledge base entry extracted by the domain experts. Based on that knowledge base, we try to identify or extract the answer, or we use some parallel development of knowledge base by distributed teams, and after that we use some knowledge formation step. This knowledge formation step is also very useful in generation of answers. Next is the comprehensive million axiom knowledge bases. We use these comprehensive knowledge bases to generate the answers or answer list, fast generation of answer list. For example, it contains some basic knowledge of space, time, causality, general physics, biology, threats like biological weapons related knowledge base. We use this knowledge base. Actually, this is a process of organizing knowledge base so that we can answer questions fastly. Some different approaches are like text match. It finds the text. For example, we have a given question like what is the largest city in England? Then this approach will do, it will find the text that says London is the largest city in the England, or perhaps apply some confidence parser, confidence score, then find the multiple sentence instances and confidence score, check the confidence score, and then say that this is the answer. Second is the superlative search. It finds a table of English city and their populations and sort them. Then find the list of 10 largest cities in the world and see which are in England, and find the population of as many individual English cities as possible and choose the largest, and the intersection of all these will give you the answer for this question. Heuristic. London is capital of England, so it may be the largest city. Not guaranteed to imply it is largest city, but this is very frequently in the case. Some complex inference based approach is used. For example, Birmingham is England's second largest city. Paris is the larger than Birmingham. Then London is larger than Paris. This implies that London is in England. So some kind of inference rule: A tends to B, B tends to C. Like A have some relations with B some relations with C. By using these relations, we can infer some relation and answer these questions. Now we'll discuss about some problem statements and supporting approaches, like what sources of information are useful for finding answers. How do we obtain and represent useful information? How do we combine multiple information sources in making a unified decision? These are the basic three questions useful for answering the factoid based question answering system. In factoid based question answering system, first, in early track system, focus on exploiting surface text information by either handcrafting pattern or automatically acquiring surface text patterns. Manually constructed surface text patterns usually give good precision but poor recall. Although automatic learning of these patterns explicitly address this issue, low recall is still identified as a major cause of bad performance in many pattern-based approaches. One solution of this problem is to combine the pattern with other statistical method. Means instead of just identifying the surface patterns means, like for example, for this, if we consider this as a question, then surface pattern will be source of information useful for finding answers, like that. In this approach, first extracted a set of some patterns by using the approach described, and then they use some maximum entropy classifier to learn the appropriate weights of these patterns on training. So based on these such type of surface text patterns, some other statistical features, and then they apply some classification techniques to rank those features in answering the questions. Another problem, as discussed by Ravichandran and Hove, is that surface pattern cannot capture long distance dependencies. The problem can be addressed by recovering statistical structure in answer sentences and enhance the patterns with linguistic constructs. So what he did, he just added some linguistic constructs and linguistic rules with identified patterns, means order of those patterns, position of noun, verb, etc. in those patterns in generating the answers. For example, a named entity based approach. The idea is that factoid questions fall into several distinctive types such as location, date, person. Assuming that we can recognize the question type correctly, then the potential answer candidates can be limited down to a few named entity types that correspond to the question type. This will be intuitive. If the question is asking for date, then an answer string is a string that is identified to be a location type. Named entity is not likely to be the correct answer. Important to bear in mind that neither question type classification nor named entity recognition are perfect in the real world. It is very important. So such system can be harmful when classification and recognition error occurs. The aforementioned two types of information, sentence surface text patterns and answer candidate named entity type, both come from answer sentence side. The only information we have extracted from the question side is the question type, which is used for selecting patterns, and named entity types for matching. So this indicates the use of named entity and surface patterns for different tasks. But the structural information in the question sentence is not available in the input in many other tasks. For example, ad hoc document retrieval has not yet been fully utilized. Recognizing this input source information, there have been many recent work finding ways to better utilizing the structural information, and we'll review them next. Model for combining the multiple source of information in answer scoring. Nearly all question answering system use evidence from multiple sources to decide what is the best answer for a given question. Actually, Lee et al. First decided the named entity type of answer candidates based on the question type, and then ranked the answer candidates based on the 4 types of evidence. First, count of named entity types that occurred in the question occurring in the answer sentences, normalized by the number of named entity type occurred in the question. Second, the count of constants other than named entity type constant that occurred in the question occurring in the answer sentence, normalized by the number of constants occurred in the sentence in the question. A preset score when the answer candidate string contains the identified questions focus string. A preset score, the answer candidate string appear in the answer sentence next to the term that contains question focus string. So all these 4 factors are combined and utilized for ranking the answer. Each listed condition will give the normalized score if satisfied, and the final scoring function is the sum of these scores. Some ad hoc feature weighting scheme, like some ad hoc feature weighting schemes are also used, like matching word. Sum of TF-IDF scores of the question words appear in the 3 sentence window. Thesaurus match, the sum of TF-IDF score of the question words whose thesaurus matching by word net appear in the 3 sentence window. Mismatching word, the sum of TF-IDF score of the question words that do not appear in 3 sentence window. Dispersion, the number of words in the answer sentence that occur between the matched question words. Cluster words, the number of words that occur next to each other in both answer sentence window and the question. Having compared these distance matrices, they use ad hoc scoring function, which was not detailed. They used those ad hoc features and calculated the final weight of their answer and used them in ranking the answers. Thanks.